Hi everyone, this is Dan from Earth Science Simplified, and today we are going to be taking a very quick look at the geological timescale. So, the geological timescale, which is shown here, is a way of relating strata to a specific moment in time. By strata, I mean a layer of rock or sediment that's separated from the other layers due to its own unique characteristics. And this is usually just rock type, but it can also be due to a number of factors, such as fossil content. So looking at this picture, you can see all of the different subdivisions such as eon, era, etc., which we will go into in a moment. But for now, you can see on the bottom right hand side, it goes all the way back to 4.54 billion years ago, and this is when we think that the Earth first formed. We largely know this thanks to this guy, the rather effeminatively named Claire Patterson. Now, Claire radioactively dated a meteorite to get an estimate of about 4.55 billion years for the age of the Earth, which is much closer than any other estimate of the time. Back to the timescale itself, let's discuss the different subdivisions that we see here. So the main one, looking at the eons, is the Phanerozoic, and this encompasses everything from today until about 541 million years ago, which is the start of the Cambrian. Now, we're mainly concerned with geology within the Phanerozoic for a variety of reasons, but firstly and mainly because there's more of it. So as oceanic crust is recycled roughly every 300 million years, when you combine this with things like metamorphism, which massively alters huge areas of rock, it gets less and less common to find original geologic features within strata of age. There are some rare rock formations that are over 4 billion years old, but they're generally only in cratonic areas of continental crust like in Greenland. Secondly, the Cambrian explosion. So when the Cambrian period began, conditions became much more favourable for life, and as a result, there was an explosion of loads of different marine species. Fossils and paleontology are really important to loads of different aspects of geology, like sedimentology or stratigraphy. So this means much more can be studied from this time onwards. So moving on to the eras, the only three that I really think are worth trying to remember are the ones in the Phanerozoic. So that's the Paleozoic here, the Mesozoic, and the Cenozoic. And it's worth trying to remember these three dates here that separate them, mainly because each one signifies a really significant geological event. So 541 million years ago, as I just said, was the start of the Cambrian explosion, where there was a huge increase in biodiversity on Earth. 252 million years ago was the PT mass extinction, and this is the largest extinction ever on the history of our Earth. 66 million years ago is one that a few of you might already know. This was when the dinosaurs supposedly became extinct. So, as you can see, each one marks a significant change in fauna and flora, and also climatic conditions to a degree. So there are 12 periods within the Phanerozoic eon. Each one is generally separated by a mass extinction. And if you can remember the actual dates that separate the time periods, brilliant. I haven't put them on here because the main thing to learn at the beginning is the order in which they come in. So I use this mnemonic to remember, because I still forget to this day. And it goes, crowds of silly dinosaurs crash past the jungle, chasing pretty nasty quarry. I don't actually know what pretty nasty quarry is, it's just what I was taught, but maybe the fact that it's a bit random can help you remember it. So finally, looking back at the epoch section, which is to the far right, I wouldn't actually recommend trying to learn these, mainly just because they're quite specific. Even now, at degree level, if I were to do something that required the use of epochs, I would have to look it up on a geological timescale, because there's so many that you're never going to remember them all. It's generally just for when you're doing a really relatively short geological time interval. So that's it for this video. As I said, it's a short one. So just to summarise, you've got your major subdivisions of eon, era and period. It's worth trying to remember as much of the Phanerozoic eon as you can, and the three main dates that separate the eras, 541, 252 and 66 million years ago. And if you can, try and get that mnemonic in your head, try and remember it. And it will come in really handy in future because it's always mentioned in geology. So for example, when somebody says, oh, I've got the Permian sandstone here and the Devonian shale, you will know that the Devonian shale is older than the Permian.